Good morning, colleagues. Today we are going to solve exercise 330 from the book Fundamentals of Electrical Circuits. In this exercise they tell me that by applying nodal analysis we must find V0 and we must also find I sub 0 in the circuit in the figure, and sub 0 would be the current that comes through here. They are no longer demarcating it, and it is sub 0. It is the tension that is in this resistance. Let's note that this circuit has a dependent voltage source and a dependent current source. This voltage source depends on 4 times the voltage that is here, which is the same voltage V sub 0, and depends on twice the current I sub 0, which comes from here. We have to do it by applying node analysis. The first thing I recommend is to do a visual analysis, right? Where currents enter and leave, helping us with voltage and current sources. For example, here in this 100-volt source, well, I know that this generates a force, or causes the current to circulate in this direction. Remember that we established this, and it does not mean that the direction of the current is right or wrong. In the end, the analysis will tell us if the current is going in that direction or in the opposite direction. That through the plus or minus signs. Now from this source of 4 dependent 4 sub 0, well, I say that it sends a current in this direction. If these two currents join at this point, and the resulting would be the Y sub 0 that comes from here, 6 sub 0 runs through this resistance, passes through the voltage source and reaches this point, this current Y sub 0, which is the same that comes here. I'm going to put here I sub 0 enter at this point. Let's observe that it is added with this current that is here. When added, well, I say that the remainder comes in this direction, and let's observe that here they give us 0 with the plus-minus polarity. This is a clue as to where the current could enter. Obviously he should enter at the top if he polarizes that way. Now I'm going to give them a name here. I'm going to call this V1. Yes, in this node I'm going to call it the V node 1, and this one I'm going to call the V sub 0 node. Why did I call it sub 0? Because between this point and this point, that is, between this point and this point, it is the same point that is here and the one that is here. Therefore the same voltage V sub 0, this resistance is the same voltage between here and the ground reference. Okay. Now, applying nodes in node 1, in node V1 we say the currents that enter this node A. Well, let's name the currents until I'm going to call it current I1, until I'm going to call it current I2, and the resulting 1 I0. What I am going to do is that in this node the currents that enter are I1 plus I2. Plus and 2. This is going to be equal to the current I0, but here it is equal, and 1 is equal to the voltage that is here, minus the voltage V1 as the current goes there, since it is assumed that if N is greater than V1, then I say that 100 minus V 1 over 10 ohms. This will give me the current I1 plus I2, which is 4 times versus 0, which is the value here. We don't know what V0 and minus versus 1 is. About 20 ohms, and that would be the I2. This is I2. This is I1, and that is going to be equal to the current that comes out, which is I sub 0, and the I sub 0 is nothing more than V1 minus V0 over. Well, here we have to look at something. We know that if the current I0 goes in this direction, it means that the voltage here is greater than the voltage here. But let's notice that here there is a 120-volt source also pointing that way. That is, this tension generates a force, it pushes there, and this adds 1 to the tension V, because between the two it generates a force there, and this would be the one that opposes it, so to speak. So here it would be V 1 plus the 120 120 that this generates plus minus v sub 0. About 40 years old. Okay. We are already here. We have already started to apply algebra. Here we have to have 100. Here I would have 100 out of 10. This is nothing more than 10 out of 10. It would be 10, 100 100 over 10 minus v, 1 over 10. Hey? Plus 4 out of 20. I'm just separating everything. Then we apply the algebra that we need minus v1 over 20 equals a v1 over 40 plus 120. Plus 120 over 40 minus v sub 0 over 40. Okay, so, let's notice that. Well, let's do the complete steps for. I'm not going to leave everything that has a variable on one side, the equal, and everything that has a constant on the other side of the equal. I'm going to pass, I'm going to spend what I have here. In other words, this thing that has a variable, I'm going to go there, and this thing that is constant, I'm going to go there. So this one here was 40, so I'm going to score first. This would be v1. About 40. Let's remember that you are only going to put what is constant. I'm not going to put this up yet, I'll put this up later. v1 over 40 minus v sub 0 over 40. And this has less. Let's remember that I'm going to pass it over there. Change plus sign v1 out of 10. What changes the most would be minus 4 out of 20. It is a surface that has less happens more a1 out of 20. Maybe now that it has constant this one that traveled there 10 and this that had positive happens with negative. It would be minus 120 out of 40. Why isn't it simplified here? Well, everyone looks for an accommodation, right? Now if I can start applying algebra, I'm going to add everything that has v1 and everything that has v0. By me doing that, I'm going to get 7 over 40 volts, 1 minus 9 over 40 volts 0. That's going to be the same. 10 minus 120 out of 40. This is going to be 7. Sure. This would be cancelo 0 and 0 would be 12 over 4. 4. To reach 12 it would be 3. 4 times 3, 12, 3 10 minus 3 would be 7. Perfect. Now I am going to eliminate the denominator by multiplying by 40 and in the end this is going to give me 7 volts 1 minus 9v0 equal to 280. It's going to be my first equation. I'm going to delete this. I'm going to work with the node that I called v0 in the v0 node. Let's remember the currents that enter are equal to the currents that leave. At this point two currents enter, the one that comes from here and the one that comes from here. This here is n0 plus 2. n0 and 0 plus 2 times. n0 is going to be equal to what comes out. The current is, I won't give it a name, it's going to be called y3 n3. So 2 times n0 plus 2 times n0. Well that would be 3 times n0, no, right. 1 plus 2 would be 3 equal to y3, but the n3 here because it would be v sub 0 over 80 volts sub 0, over 80. Now, I have to 3 times and sub 0 equals v sub b sub 0 over 80. I can wait and sub 0 I can say that and sub 0 is equal to. I can divide it by 3. There would be 24. There would be 240. Hey? I could skip it, but I'm going to leave it. Yes, let's pass. It would be V sub 0 over 240. Now what is 0? Well, I sub 0 is the current that comes from here. So we have to replace I sub 0 so that we are left in terms of voltages and sub 0. I'm going to put it here on the side. Let's remember that it is equal to well, let's put it directly B1 plus 120 minus V sub 0 about 40. That's I sub 0. All of this is I sub 0 and sub 0. It has to be equal to V sub 0 over 240. Okay. Then I start open. I have here that P1 over 40 plus 120 0 plus 3 minus times 0 over 40 is equal to 0 over 240. Okay. Now let's start applying algebra. Let's lower this a little bit to have more space. So I'm going to leave everything that has a variable on one side of the equal. So here I have to V1 over 40. Minus V sub 0 over 40. Notice I put this one. I put this and this. I'm going to pass it on this side. It would be minus the sub 0 over 240. It will be equal to minus 3. Okay. So V 1 out of 40. So I minus 1 out of 40. 1 out of 40. I subtract 1 out of 240. And that's going to give me minus 7. About 240 V sub 0 equal to minus 3. Let's eliminate the denominator. I'm going to multiply by 240. Multiply it by 240. Hey, 240 divided by 40 would be 6. This would be 6 volts 1000 with 240. It would be minus 7 volts sub 0 equal to 720 negative number. Here a negative. This would be my equation number 2. Okay, I'm going to delete. Well, you can rewind the video whenever you want. And we are going to put all this into the calculator. There are different methods. This is possible. This can be solved by calculator. But I like to use MATLAB for when we get to the phasors topics. I have here 7 space minus 9 semicolon 6 space minus 7 and here it would be 280 semicolon minus 720. We corroborate 7 minus 9287 minus 9286 minus 726 minus 7 minus 720 as we solve and obtain these values. Let's notice that here they tell me minus 1.6880 but it's Euler at 3. It means that we have to multiply each of these values by 3 or it is in kilovolts, so to speak. So I can put here, A, that B1. B1 and B0. This is in. Let's observe minus 1.6880 minus 1.6880. I can say that it is kilovolts or minus 1.3440 minus 1.3440 kilovolts. That's what it tells me here. Times 10 to 3. I have to multiply it by 1000 or this. would be equal to 1000 minus 1688 minus 1688, and here it would be minus 1344. They were asking us that 0. These are volts. We already have it. We already have 0. We need to find ES and sub-0 and sub-0. Let's notice what I'm going to delete here. I wouldn't have deleted it and sub-zeroed the current that comes through here. So this 0 is equal to AB1B1 minus 120. What's more, remember that this is adding to the strength you are doing. They are both making a force towards there. That is why it is more, so that if the remainder is minus 0. About 40 ohms. How can we do this? Let's do it with MATLAB. Let's remember that this would be solution 1 plus 120 minus solution 2 here if I did it. Well, I put it variable alone solution 1 in position 1 because it gives me the value 1, and in position 2 it will give me the value 2. So let's note that this would be the solution in position 1. Yes, because it is B1 B2 plus 120 minus solution in position 2 everything over 40. Let's do it with MATLAB. I'm going to put here the solution variable in position 1 plus 120,120,120. It doesn't hurt to check 120 minus solution in position 2. I'm going to close all that in parentheses. All of that is going to be about 40. I just go to enter. And it tells me that the current is minus 5.6 amps. The current and sub-0. Minus 5.6 amps. Well, that's it. So, see you in the